Hey. Okay, so we continue the conference with the hot topic about AI with our next speaker. He is the CTO and co-founder of Iris.ai, and he's going to talk about the role of AI in the future of knowledge. Let's welcome on stage Victor Botev.
Thank you, everyone. It's really nice to be here. I'm Victor Botev, as already mentioned, and I will be talking today about the future of knowledge and, in general, about knowledge, about what and how we have used knowledge in the past, and how we will be doing that in the future, and what's the role of AI in that. And first, I'll start by saying a few words about what is actually knowledge. So already back like a few thousand years ago, people have started using knowledge more, how to say, more aware that this thing needs to be learned, propagated, transferred, and so forth. But what is knowledge? So knowledge is actually a unit of information that is describing the world around us. It could be in any form or type. Actually, if you look at evolution, for example, knowledge is already inside each and every being that exists today and that has existed in the past. So we have it in our cells, we have it in the RNAs, we have it into the DNA, and that is something that has been encoded there. It changes, it moves forward, it's transferred from being to being. But after a certain time, like when the civilization started to grow, actually we started to build external knowledge systems. So this we can call like internal systems. That's how the evolution works and how the nature works. But we started building external systems, like there were libraries, we wrote books, there were paintings and things like that. And that's how kind of knowledge started going out of the body and the beings and going into external systems. But how do we, in general, work with knowledge? So basically, we need to acquire some new knowledge somehow, new information about the outside world. After that, we have to encode it in one way or another, store it somewhere, then decode it back again when we need it, and interpret it. And after that, we can apply it to certain use cases. So if we look at some examples, so for example, someone actually did something incredibly innovative in agriculture, for example. Then after that, they wrote a book that's kind of encoding the knowledge using language. Then they store it into the book. That book went into, let's say, the Library of Alexandria. Then after that, it has been decoded by someone else who just read the book. And then it put his own interpretation about what this knowledge is about. And after that went, let's say, to some other parts of the world and start applying the learned knowledge in reality. So how do we use knowledge in the modern age? Like this was a little bit back in the day, but how are we using knowledge today? So of course today computers are one of our main kind of storage systems for knowledge. But we also have like textbooks, like everyone in school still study using textbooks from time to time. We have peer-to-peer systems, meaning that we actually meet with some people, we meet with our peers, we meet with teachers or lecturers and so forth, and we exchange knowledge between each other. And as I said already, we have also the computers, data centers, data lakes, cloud storage, all of this stuff. To actually store the knowledge and the information units that describe the world today. What are, for example, like modern decoder system? I'm not going to go into the encoding part because that's a whole different story. But more interestingly are how do we actually work with this stored knowledge today. So, for example, for textbooks, we use kind of teachers who kind of distill the knowledge that's in the textbook and tell us what examples to use. The peers can do the same. We also have, when it comes to digital systems, a lot of other tools to actually consume knowledge, like their interactive interfaces that present us like nice connections of data. You know, we have like statistical charts and all of these things. There are audio recordings and audiobooks that tell us what the knowledge is about. There are videos, explanatory videos, probably one of the most kind of advanced ways of learning knowledge today is because in videos, you actually can see how the things are applied, which can reduce the errors that can happen when you interpret the knowledge. Because one thing is to read it in the book, another thing is to just apply it like on some controlled environment, but a totally different thing to actually see how someone else is doing that. In this kind of process, you use all of your kind of internal knowledge of the world, of how you move, how things move, and that actually is one of the best ways we have to date to help decoding the knowledge that exists in our systems. But in general, still today, the consumption of knowledge is left to a big extent to the receivers. So it means that the people that actually receive the knowledge, they still interpret it in their own way, sometimes correctly, sometimes not so correct, and then they apply the knowledge in practice. So what are, in general, the issues in the knowledge chain? So the issues in the knowledge chain, they start with each and every action that we just described. So issue number one is usually information loss, because at the moment you actually have to encode something, and you can imagine that the farmer that actually created these amazing canals in the ancient Egypt, they actually had this experience, you know. So they felt everything, they did everything with their hands and stuff like that, but then after that they just have to write it in text, right? So during this kind of encoding process and explaining it into language, there is information loss. So we lose some of the parts of the experience that actually existed. Interestingly, actually even our brain works a lot with this process of information loss. I mean, it's studied quite a lot that when we experience something, our brain just remembers some associations of the experience that we had, and then if we just try to recall it, we actually don't really remember the full experience, but we just reconstruct it based on these associations. So essentially, you can, I mean, there are studies of how different memories evolve over time, and you can see that there is a lot of information loss into that process. So besides the information loss, there could be errors, of course. There could be errors because we are trying to explain something in a certain way, or there could be errors because we just made an error. There are also time-based errors, because at the time when we actually record the knowledge, there could be certain, how to say, general understandings of the language or of how things should be presented. And those things might change. So if you read a book, for example, from, let's say, the 1800s, you can see that there are certain things that people expect you to know while reading that are no longer reasonable today. So those are like kind of time-based errors. Not to mention that actually there are storage problems when you store knowledge for a long time, like the books can get dirty or something get wrong. And they, even in like modern systems like computers, if you store something for very long, you might get the knowledge corrupted. There's also errors during decoding process. That means that people that are actually reading things might have issues with understanding properly the language, with having the proper background to understand it, and so forth. But everything kind of leads to what we call misinterpretations or misunderstandings. So misinterpretations are one of the most kind of, well, one of the biggest enemies of knowledge, basically. Because when someone tries to understand what has been encoded and stored, and they interpret it in the wrong way, then bad things can happen, actually. And that's what we want to avoid. And so when we work with our current digital systems, there has been a lot of effort streamlined towards how to mitigate each and every of these issues in order to be able to actually prevent misunderstandings at the end. But this is something that has been, so this kind of errors and this effort towards errors, this was part of the digitalization era. But things have changed in the latest 5-10 years when it comes to knowledge in a way that changes a little bit the perspective. So before, although there were errors, the knowledge is kind of structured in a way. It is possible for the people that want to learn things to actually consume that knowledge. But today, the amount of knowledge that is available out there, grows exponentially. So we have actually, back in the days when we started Iris.ai, because we actually work a lot with knowledge, there were about 6,000 research articles published every day in the whole field of science. Well, just for 5 years, they have increased to about 30,000 a day. And you have also a lot of other technical reports and patents and other things like that that just add more and more new things that people find and want to encode and want to share and transfer to each and every one of us. But this introduces new kind of issues. So the time actually, because when you have the knowledge and you want to learn it, there is some time requirement. You need some time to actually practice it, to apply it to several use cases in order to be able to understand and use it in your day-to-day life. But the time for acquiring it has become so short because the new thing is coming up and the new thing we have to learn and so forth, that time becomes a big pressure factor when it comes to consuming and using of knowledge. And one interesting study that I want to mention here is about what would be the most important skills of the workforce, and especially in the IT sector, in the next 10 years. This study has been done by IBM. And one of the most important skill actually was time management. And what they mean by time management is exactly that thing, that you need to manage your time about what things you want to learn when, because new things will be coming up. And if you want to be competitive in the market, if you want to have an edge, you have to very well manage your time and use tools to actually provide you knowledge in order to develop yourself. So time has become a big factor here, but there is also some limits to the capacity on the user side, meaning that we cannot, there are a lot of things going out and we want to learn everything about, let's say, LLMs, then we want to learn everything about prompt engineering, then about, okay, so how to train the models, how to use them, what are the best interfaces for them, and all of these interesting things. But it becomes like a little rabbit hole, and that's about just one topic. But what if we also want to learn about other things? So besides the time management, the other important thing is to actually be able to manage the capacity which we have and choose wisely which things to learn. So that presents also these scalability issues. So how people have targeted misunderstandings in the past? Well, there are several layers of verification and validation when it comes to writing, editors, and so forth. There were improvements in terms of encoding and decoding. There's the digital era with algorithms, manual effort for interpretations, and so forth. And the focus in general has been in the past to unify the knowledge so that it's useful to everyone, so everyone can adjust to that. Well, with the scalability issues present, that becomes a little bit of a problem because with the exponential growth of the digital platforms, of the knowledge that is around us, it's no longer possible to adapt well to this general common understanding of the knowledge. That's why textbooks have diminished a little bit their role, and we have seen videos which are much more personalized. We have seen more peer-to-peer systems and so forth. But no tooling is actually enough when it comes to our own capacities. And here is where, we have seen all the developments of the AI in the latest years, the LLMs, and one of the most important things that LLMs can do is that they actually can decode knowledge pretty well. So that's why they can also write plausible text. But the other important thing is that they can translate. So they can understand the intent of the user. They can understand our vocabulary. So whenever we want to ask questions and we want to get answers, we will get them personalized to ourselves. And that gives us the capacity to actually more quickly get to the point of understanding the knowledge. So, and that also bridges the gap a little bit between the person that encoded and stored the knowledge and us on the other side, which we have to receive it. So that's where AI systems will play a bigger part in the next 5 years probably, and maybe a little bit longer. But the idea basically is that they bring personalization. And that is, in my view at least, that there is a new era of personalization that is starting. It has started already last year. But with these AI tools, we'll be able to do things like personalized medicine, by like personal tutors for certain activities, and so forth and so forth. So suddenly, we have the AI from like the servant to somehow become more as a master of in the relationship between us and the AI. But what prevents us today to actually have this personalization already happening? Well, one of the biggest issues with LLMs is their adherence to facts. So essentially, we have all seen what was discussed already today, hallucinations. But those hallucinations are mostly present when it comes to direct factual data. And there is a pretty good explanation about it, because with all the breakthroughs in the attention mechanisms for transformers, they actually taught the LLMs to generalize. So the idea is that they generalize knowledge, they encode it well, they are able to paraphrase, they can build you nice text that actually paraphrase a question, answer the question. But this generalization doesn't work well for facts. So what we need to do is we need to help the LLMs get the facts right, and in this build bigger trust in those systems. Also, another kind of issues is that the current tech is a bit too expensive. So if you really want to train and fine-tune a model for your particular use case, then that might be a bit expensive. And finally, of course, there is this adoption barriers. Like, as it was mentioned in the previous talk, like right now we have returned to the 90s, where the main interface to interact with the machine is chat interface or like console, which, I mean, kind of tells us that we probably have to do something in order to make this more interactive, because people usually use their visual memory much more often than anything else. So a few words about how can we make actually factuality the focus of these LLMs. Some of the things that we have done in the past few years are related to using structured knowledge. So the idea of using basically knowledge graphs with LLMs in order to produce factually correct results. High quality data, and here we're not talking about just cleaning the data. We're talking about the fact that when you train a large language model just on text, it doesn't have the same capabilities as if you train it on more structured data sets, and I'll just mention them in a second. But so just if you train it just on text, it doesn't have reasoning capabilities and abilities to follow instructions. But if you train it on textbooks, on code, on scientific texts, then suddenly the reasoning capabilities rise a lot. So we have to think about, okay, what is this data that brings structure to the knowledge inside the LLMs, so that first we reduce the cost, we reduce the number of parameters and things like that. And second, we get better reasoning capabilities. And finally, we should focus on facts. So the current attention mechanisms are focusing on generalization, which is great, and that's why we have these breakthroughs. But now we need to change that slightly and give it the ability to understand that if there is a factual relation, it has to put the right facts there and shouldn't generalize. It should, I mean, it knows sometimes there is a phone number there and puts a random phone number. So no, we want the actual phone number of the person that is in the answer. Cost optimizations, I think that relates to the previous slide a little bit. It's all about parameter reduction. avoiding the need for fine-tuning and infrastructure. So we need to do improvements in infrastructure, but by using the right data and at the same time combining the structural knowledge with the prompts, we can at the end avoid the need for large-scale fine-tuning. Architectural shifts. So things have changed. So we have encoder models that were back like 10 years ago. Now we have decoder models that are the central focus, GPT models. And there are some experiments with encoder-decoder models, but the problem is that they require even more computational power and data. So that probably will change a bit in the future, and we'll move more towards that because we do want to have the knowledge and the decoder in the same place, but it will take some time. And yeah, finally, we need to teach people a little bit also about how to use these systems. Like, yeah, a lot of people are in denial of using them. A lot of people resist that they should use those tools in their day-to-day life. But reality is that without them, our capabilities will actually diminish quite a bit compared to people that are using them. And finally, I just want to show you one example, because I talked a lot about structured and unstructured knowledge, LLMs, and things like that. So one example about how you can guide an LLM by using a knowledge graph. So on one side, you have like just an excerpt of the knowledge graph, which has been identified by the entities in the question. And then after that, you kind of ask the large language model to follow that structure and identify what is the compound, what is the side effect, what is the cause of the side effect, and so forth. And by the large language model describing these things, it automatically reaches the correct answer. So while the original answer could be wrong, I mean, it can be random, actually it changes. If you ask the same question 3 times, you get different adverse effects. But in reality, if you guide the model with these structures, it gets the concrete entities correct. And even if you ask it, okay, so was your previous answer correct after you identify the entities and after you follow the relations, the model actually can say, no, actually, I was wrong, so I will change my answer. And what we are doing is we are building those automatic loops underneath in our Iris.ai scientific chat tool, so that at the end of the day, the users actually get the factually correct answers. And that's just one of the things that can be done in order to increase the factual correctness from like 60% what it's today to like 90%. Yeah, thank you so much.
Thank you, Victor, for the inspiring AI presentation. So now it's time for Q&A session. You can ask your questions if you have any to Victor. Take your chance. Yeah?
I was not able to fully hear the question, so if you, yeah.
So, hi, thank you for the talk. Can your product be incorporated in the peer review process for papers, since it's gathering knowledge and validating it?
Yeah, actually, there have been a lot of inquiries for using these kind of tools for peer reviews. Definitely, there are possibilities for that. One of the issues there, and it's not related at all to technology, like technology can be used there. One of the issues there is usually the business model. So, because when it comes to the peer-reviewed process, in many situations, it's actually volunteer, and it's really hard to engage people in both kind of testing and validating the technology, but also for the company that builds the technology, it has to have some other business, and this is always kind of the side business. So that becomes a little bit of a problem when it comes to this particular use case. But definitely it can be used, and yeah, I hope that the whole ecosystem in academia, when it comes to peer review, will change in the future, because right now this area is a little bit, how to say, undervalued, and at the same time it's very important for the quality of knowledge. So I think it's a bit overlooked, and it has to change.
Thank you.
So you talked about ways to make AI give more factually correct answers. I've read quite a few articles, theoretical, about how it is very difficult to make AI give truthful and correct answer. So how close to the correct answers to the correct factual information do you think you can get with the methods here? And I suppose you've also read the same articles.
Yeah, of course. So that's our area of expertise. So I can talk a lot about that, but I'll try to be short. So they're basically, so you're right. I mean, it's extremely hard because that's the essence of the current architecture. So the essence of the transformers and the attention mechanisms is for the models to generalize. And it's really hard to try to teach them to be factually correct. Actually, if you try to do that just with training data and fine-tuning, that's not possible today. So you have to think of other ways in order to do that. I mean, chain of thought and graph of thought is one way through the prompting. And the reason why it works better through the prompting is because the models have internally learned some instructions, and they are kind of bind to those instructions. And using the prompts to kind of trigger those instructions helps in them producing the right answers. So through prompting, we can do certain things. So that's one very important thing to note. Second thing, right now, there are no good metrics to actually measure factuality well. So we need proper data sets in order to be able to measure factuality. I mean, in our particular company, we do have them because we have worked with extracting factual data for other purposes, for extraction purposes, for a lot of companies. So we have those knowledge graphs with factual data with which we can measure. And on certain domains, we really achieve very high level of factual correctness. As I said, like the fundamental models, they have factual correctness between 40 and 60%, meaning that, yeah, like in 40% of the, or 60% of the answers, you get the facts, all of the facts correct. In all the other answers, you actually get something wrong. So with adding additional layer of guiding the models, you can reach 70, 80%, but you need, so it depends how specific are the questions, which is the domain, is there enough knowledge so that you can have a full factual graph and things like that. But the other things that have to be done is there are ways to do knowledge injections. So you can actually use adapters in the transformer mechanisms to train certain layers of the neural network in order to ingest or impute the knowledge from the knowledge graphs. And this requires a little bit more specific data in how to basically teach the model the relationship between the different facts. And those layers are actually the ones that kind of add, so they create some sort of a heat map of the answer, and the heat goes to the factual elements, and it helps the model to actually not try to generalize on them. But it's not an easy process and still needs to be investigated or researched a bit more. And the final third way of doing that is through changing the attention mechanism. So that's actually the most important thing, and it will happen in the next year probably. The attention mechanism will be changed with a hybrid mechanism, one for attention, but one also for generating these automatic heat maps of the produced text. In order to identify the factual elements, it will happen a little bit in backtracking order. So we'll probably not guess the next token, but we'll guess the next sentence. And then after that, we'll be able to analyze the sentence. But yeah, I mean, these are things, for example, on this final point, we are working with UCL, the College of London. So, and with them, we are trying different. We're doing different experiments with the mathematics behind the attention mechanisms, and trying to combine it with more like focusing mechanism as well. Yeah, I hope that answered the question.
Okay, so I think that we don't have more time for questions. Thank you again. You can find Victor outside, and let's have a quick 10 minutes break. Thank you.
Thank you so much.